Picture this. You're an astronomer.
Yeah.
Back in 1998, you're peering deep into space, expecting, to find evidence that the universe's expansion is slowing down.
Right, because of gravity.
Due to gravity,
Okay.
exactly.
Yeah.
And instead, you discover the opposite.
Yeah.
The universe is speeding up. It's like throwing a ball up in the air
Yeah.
and watching it accelerate upwards instead of falling back down.
Wow.
That's the mind-blowing discovery that led to the concept of dark energy.
Yeah.
Welcome to Cosmos and a Pod Space and Astronomy series.
Absolutely.
So we're diving into the mystery of dark energy.
Okay.
This invisible force that seems to be pushing everything apart. It makes up a whopping 68% of the universe.
Wow.
But we have no idea what it actually is.
Yeah.
It's like trying to understand the engine of a car by only looking at the exhaust fumes.
That's a great analogy. The discovery of dark energy really shook the foundations of cosmology. It challenged our understanding of gravity and forced us to consider entirely new possibilities about the nature of the universe.
It's like realizing there's a whole other set of rules governing the cosmos that we're just beginning to glimpse.
Right.
So how did scientists even stumble upon this invisible force in the first place?
Well, it all started with those distant exploding stars called supernovae.
Okay.
Astronomers were using them as standard candles objects with a known brightness to measure cosmic distances. But they noticed something strange. These supernovae were much fainter than expected, which meant they were farther away than they should have been, based on the universe's presumed rate of expansion.
So it's like looking at a streetlight and realizing it's much dimmer than it should be.
Exactly.
Meaning it must be farther away than you thought.
Exactly. And that's how astronomers realized that the universe's expansion wasn't slowing down as predicted. It was actually speeding up.
Wow.
This unexpected acceleration pointed to the presence of some unknown force counteracting gravity, which we now call dark energy.
That's incredible.
Huh.
But supernovae aren't the only evidence for dark energy, right? It's not like scientists base such a huge concept on just one observation.
You're absolutely right. There are multiple lines of evidence, like pieces of a cosmic puzzle that all fit together to reveal the picture of dark energy.
So what are some of these other pieces of the puzzle?
Well, there's the cosmic microwave background, or CMB,
Oh.
which is like the afterglow of the Big Bang.
Okay.
This faint radiation that permeates the universe,
Yeah.
carries information about its early composition and evolution.
Uh-huh.
And guess what? The patterns in the CMB also point to the presence of dark energy.
Wow. So we're talking about signals from the very beginning of the universe.
Yes.
Confirming what we see with supernovae billions of years later.
Exactly. It's remarkable how these independent lines of evidence converge. But there's more.
Okay.
The way galaxies are clumped together and spread out across the universe,
Okay.
what we call the large-scale structure, also provides clues about dark energy.
So even the way galaxies are arranged tells us something about this invisible force.
It does. Imagine you're looking at a spider web. The pattern of the web, how the threads are connected and spaced out, tells you something about the forces that created it. Similarly, the large-scale structure of the universe tells us about the forces that have shaped it over billions of years, including dark energy.
It's fascinating how scientists can extract such profound insights from seemingly simple observations.
And then there's another fascinating piece of evidence called baryon acoustic oscillations, or BAOs for short.
BAOs, you mentioned that earlier, but what are those exactly?
Imagine sound waves traveling through the early universe,
Okay.
creating ripples of density variations. These ripples, frozen in time as the universe expanded, act like a giant cosmic ruler, allowing us to measure distances across the cosmos.
It's like looking at the rings of a tree and using them to determine its age and growth patterns.
Precisely. And the spacing of these BAOs,
Yeah.
these cosmic ripples, tells us that the expansion of the universe is indeed accelerating, confirming the presence of dark energy.
So we've got supernovae, the CMB,
Yes.
the large-scale structure of galaxies,
Right.
and these BAOs all pointing to the same conclusion. Dark energy is real, and it's pushing the universe apart.
That's right. The evidence is overwhelming, but now the big question is, what exactly is this mysterious force?
Yes. We know it exists, but what is it made of? Where does it come from? What are its properties? It's like finding a strange new creature and trying to figure out where it fits in the tree of life.
That's where things get really interesting. And that's what we'll delve into next. Welcome back to Cosmos in a Pod.
Where we're grappling with the enigma of dark energy.
Yeah.
Before we went away, we were talking about how astronomers discovered this invisible force that's pushing the universe apart.
Right. We discussed the multiple lines of evidence from those dimming supernovae to the cosmic microwave background radiation, all pointing to an accelerating universe.
So we've established that dark energy is out there.
Right.
But what's really fascinating is that it's forcing physicists to rethink some of the most fundamental ideas about the universe.
Yeah.
It's like finding a missing piece of a puzzle
Uh-huh.
that doesn't quite fit,
Mm-hmm.
making you question the whole picture.
Absolutely.
Yeah.
Our current theories, like Einstein's theory of general relativity and the standard model of particle physics, are incredibly successful in explaining a vast range of phenomena, but they don't fully account for dark energy. It's like having a beautifully designed machine where one crucial gear is missing.
So what are the leading contenders for explaining this mysterious force? What are some of the theories physicists are exploring?
Well, one idea is the cosmological constant,
Oh,
a concept that Einstein himself introduced and then famously rejected, calling it his biggest blunder. Ironically, it might turn out to be one of his most prescient insights.
okay. So what is the cosmological constant and how does it relate to dark energy?
Imagine that empty space itself has a certain inherent energy,
Wow.
a kind of baseline energy density that permeates the entire universe.
Okay.
That's the essence of the cosmological constant. And this energy, even in the absence of matter, could exert a repulsive force, driving the expansion of the universe.
So empty space isn't actually empty. It's like saying even a vacuum has a tiny bit of energy pushing outwards.
Exactly. It's a mind-bending idea. But it fits surprisingly well with some of our observations of the universe's acceleration. However, there's a big problem.
What's that?
The value of the cosmological constant predicted by quantum field theory is vastly larger than the value we infer from observations, like ridiculously larger. It's one of the biggest discrepancies in all of physics.
Okay, so if the cosmological constant is causing this acceleration, why is there such a huge mismatch between theory and observation?
That's a million-dollar question. It's a major headache for physicists. Some theorists believe it's a sign that we need to modify our understanding of gravity, perhaps coming up with a new theory that goes beyond Einstein's general relativity.
Modified gravity. So maybe our understanding of how gravity works is incomplete.
Exactly. It's possible that at cosmic scales, gravity behaves differently than we expect. There are many modified gravity theories out there, each with its own quirks and predictions.
So if the cosmological constant isn't the answer, what are some of the other possibilities?
Well, another intriguing idea is called quintessence.
I know.
Instead of a constant energy density, quintessence proposes that dark energy is a dynamic field that can change over time.
So dark energy could be getting stronger or weaker as the universe evolves.
Precisely. And this variation in strength could have profound effects on the universe's expansion rate and ultimately its fate. Imagine a cosmic fluid that permeates all of space, and its density and pressure can fluctuate, influencing the expansion of the universe.
It's almost like dark energy has a mind of its own, shaping the destiny of the cosmos.
That's a poetic way to put it. And then there are even more exotic possibilities, ideas that push the boundaries of our current understanding.
Like what?
Well, some theories suggest that dark energy might be a manifestation of extra dimensions, curled up and hidden from our perception. Or it could be some kind of emergent phenomenon, a property of space-time itself, arising from the complex interplay of quantum fields.
Those are some truly mind-bending ideas. It's incredible to think that this invisible force is pushing us to consider such radical concept.
It is. Dark energy is like a cosmic Rorschach test,
Yeah.
forcing us to confront the limits of our knowledge and to imagine new possibilities.
So with all these competing theories, how do scientists go about trying to figure out which one is right? How do we study something we can't even see?
That's the challenge, isn't it? We can't directly detect dark energy in a lab,
Right.
but we can observe its effects on the universe. That's where those powerful telescopes and observatories come in. They're our eyes on the cosmos, allowing us to probe the universe's expansion history and map the distribution of galaxies with incredible precision.
We talked about the Hubble Space Telescope and the upcoming Vera Rubin Observatory, but there are many others, right?
Absolutely. We have space telescopes like the Euclid mission and the Nancy Grace Roman Space Telescope, both specifically designed to study dark energy. And here on Earth, we have large ground-based telescopes like the Very Large Telescope and the giant Magellan Telescope, all contributing to our understanding of this mysterious force.
So it's a global effort, a collaboration of scientists from all over the world,
Yeah.
pooling their resources and expertise to unravel this cosmic mystery.
It is. And it's not just about observation. We also have powerful computer simulations that allow us to model different dark energy scenarios and see how they affect the evolution of the universe. It's like running virtual experiments on a cosmic scale.
So by comparing these simulations with real-world observations, Scientists can start to narrow down the possibilities and refine their theories.
Exactly. It's a constant interplay between theory and observation, a back and forth that pushes us closer to understanding the true nature of dark energy.
It sounds like we're on the verge of some major breakthroughs.
Hmm.
Are there any specific experiments or projects that have you particularly excited?
Well, one project that's generating a lot of buzz is the Dark Energy Spectroscopic Instrument, or DEI.
DI, you mentioned that earlier. It's creating a 3D map of the universe, right?
That's right. DEI is mounted on a telescope in Arizona, and it's designed to measure the spectra of millions of galaxies, creating a vast 3D map that will reveal the universe's structure and expansion history in unprecedented detail.
It's like creating a Google Earth for the entire universe.
That's a great analogy. And by analyzing the patterns in this map, scientists hope to gain new insights into the nature of dark energy and its influence on the evolution of the cosmos.
So DSI is like a powerful new tool that's giving us a much clearer view of the cosmic landscape.
Exactly. It's just one example of the many innovative projects that are pushing the boundaries of dark energy research. And with each new discovery, we're getting closer to understanding this fundamental force that's shaping the destiny of the universe.
It's truly remarkable to think that we're living in a time when we can explore such profound mysteries. But before we get too lost in the vastness of the cosmos, I think it's important to bring it back down to Earth, so to speak. Why should our listeners, who may not be physicists or astronomers, care about dark energy?
That's a great question. It's easy to get caught up in the scientific details, but ultimately, dark energy is a reminder that we live in a universe that is far more strange and wonderful than we ever imagined.
It's like a cosmic wake-up call, reminding us that there's so much more to reality than meets the eye.
Precisely. It challenges our assumptions,
Yeah.
expands our imagination, and inspires us to explore the unknown. And even if we never fully understand dark energy, the quest to unravel its mysteries will undoubtedly lead to new discoveries and technologies that will benefit humanity in countless ways.
It's like the Apollo program, which not only landed humans on the moon, but also spurred countless technological advancements that we still benefit from today.
Exactly. The pursuit of knowledge, especially knowledge about the fundamental nature of the universe, always has ripple effects. It expands our horizons and opens up new possibilities that we can't even foresee.
That's a powerful thought. So even if we never fully grasp the true nature of dark energy, the journey of exploration is just as important as the destination.
Absolutely. The quest to understand dark energy is a testament to human curiosity, ingenuity, and our insatiable desire to explore the cosmos.
Well said. Now, before we delve into the potential fates of the universe, let's take a moment to consider the broader implications of what we've learned so far. What does the existence of dark energy tell us about our place in the universe?
That's a deep question. I think in a way, dark energy is a reminder of our cosmic insignificance. It shows us that we are but tiny specks in a vast and ever-expanding universe, governed by forces we barely understand. But at the same time, it's also a testament to the power of human intellect. We have the capacity to unravel these mysteries, to push the boundaries of knowledge, and to glimpse the true nature of reality.
It's a humbling and inspiring realization all at once.
It is, and it's a reminder that the journey of discovery is just beginning.
So we've explored the evidence for dark energy, and we've delved into some of the mind-boggling theories about what it might be.
We've talked about the cosmological constant quintessence modified gravity, and even the possibility of extra dimensions.
It's incredible to think that this invisible force, which we only discovered a few decades ago, has the potential to rewrite our understanding of the universe.
It really highlights how much we still don't know about the cosmos.
Exactly. It's like we've stumbled upon a whole new continent on the map of physics, and we're just beginning to explore its uncharted territories.
And who knows what wonders and mysteries we'll uncover along the way.
Speaking of mysteries, we've touched upon the implications of dark energy for the fate of the universe.
Right. We've discussed scenarios like the Big Freeze, where the universe keeps expanding forever, eventually becoming cold and desolate.
And then there's the Big Rip, where dark energy gets so powerful that it rips apart everything, from galaxies to atoms.
It's a pretty dramatic ending, to say the least.
It makes you wonder if there's a cosmic drama unfolding on a scale we can barely comprehend.
There is. And dark energy is one of the key players in that drama.
So if dark energy is driving the universe's expansion, what does that mean for the future of everything? What's the most likely scenario based on what we know now?
Well, if dark energy continues to behave as we observe it today, the most likely scenario is the Big Freeze.
The Big Freeze. Paint a picture for our listeners. What would that look like?
Imagine a universe where galaxies are constantly moving farther apart. the space between them stretching like an endless rubber sheet. Over billions of years, stars will burn out, galaxies will drift apart, and the universe will become increasingly cold and empty.
A cosmic ghost town, with the remnants of stars and galaxies scattered across an immense void.
It's a rather bleak picture, but it's the most plausible scenario based on our current understanding of dark energy.
Is there any chance that things could go differently? Could dark energy change its behavior, leading to a different fate?
It's possible. One of the big questions is whether dark energy is truly constant or if it can evolve over time.
So we're not even sure if this invisible force is a steady hand or a wild card.
Exactly. If dark energy is dynamic, if its strength can change, then the fate of the universe becomes much more uncertain.
It's like realizing that the script of the cosmic drama is still being written.
That's a great way to put it. And that's why scientists are so eager to study dark energy in more detail. The more we learn about its properties and behavior, the better we'll be able to predict the universe's ultimate destiny.
It's fascinating to think that the fate of everything could hinge on the whims of this invisible force.
It is. And it's a reminder that we are part of a universe that is far more complex and dynamic than we ever imagined.
So as we wrap up our deep dive into dark energy, what are some of the key takeaways you'd like our listeners to remember?
Well, first and foremost, I hope they come away with a sense of awe and wonder at the sheer scale and mystery of the universe.
It's hard not to feel a sense of awe when you contemplate the vastness of space and the forces that shape it.
Exactly. And second, I hope they appreciate the incredible ingenuity and dedication of the scientists who are working tirelessly to unravel these cosmic mysteries.
It's a testament to the power of human curiosity and our desire to understand the world around us.
Absolutely. And finally, I hope they take away a sense of hope and optimism.
Hope and optimism in the face of a universe that's expanding forever and might eventually end in a big freeze.
Yes. Because even though the universe might be vast and indifferent, we are not. We have the capacity to explore, to discover, to learn, and to create.
It's a reminder that even in a universe governed by seemingly impersonal forces, there's still room for wonder, meaning, and purpose.
Beautifully said.
Well, on that note, I think it's time to wrap up our cosmic adventure. Thanks for joining us on this journey into the mysteries of dark energy.
It's been my pleasure.
And to our listeners, we encourage you to continue exploring the wonders of the universe. Keep asking questions, keep learning, and never lose your sense of awe.
And don't forget to follow and subscribe to Cosmos in a Pod for more explorations of space and astronomy.
Be sure to check out our YouTube channel for even more cosmic content. Until next time, keep looking up.